Too easy. Alright. So this is reverse engineering Swift apps. So who am I? My name is Gianarakis. I'm the director of Spider Labs APAC at Trustwave. I organise a meetup in Brisbane, in Australia, where I'm from. And you'll probably see a whole bunch of references to like ducks throughout this presentation. It's kind of stupid, it's just a bit of an in-joke that we have with a few of us in Australia. So just kind of roll with it. Yeah, follow DuckSec on Twitter if you're interested. Alright, so the motivation behind this talk. So we do a lot of mobile app testing at Spider Labs, and we're seeing more and more Swift being used in apps that we test. So like fanboys like me like to adopt new Apple technology quickly, and so developers are picking it up relatively quickly. I even read that Google is considering using Swift as a first-class language on Android, which would be cool. Like cats and dogs living together peacefully. So yeah, I mean it's becoming a more prominent language in what we do, and so I wanted to dive into some of the key differences with Swift and look at the challenges with respect to pen testing Swift applications. So the focus of this one is on the black box app pen testing. So for a deeper dive into sort of Swift language RE and looking at the API and all that kind of stuff, Ryan saw sort of talk at Infiltrate in the US earlier in the year, and it's a pretty cool talk. So check it out. I think there's a video up now as well. Cool. So how does Swift affect testing mobile apps? So I'll dive into detail in the presentation, obviously, but the reality is that in most areas it doesn't really affect it all that much. Most issues that you would come across on an iOS or an OS 10 pen test are really due to poor design decisions and misconfiguration of the various frameworks, both made by Apple and third parties. So a lot of the issues that you would find anyway are kind of language agnostic. But obviously there are some changes, and one of the main things that has changed is how you reverse engineer the application. So one of the first things you will always do on an app test is reverse engineer it, to get an understanding of how it's working and look for vulnerabilities. So before I dive into that, I'll just give a quick overview of Swift, just so everybody's kind of like on the same page. So Swift is a compiled language that was created by Apple. It was released publicly in 2014 at WWDC and has seen multiple revisions since. It's open source with official implementations for iOS, OS 10, which I should call it Mac OS now, I suppose that's what they want to do, and Linux. And obviously it's intended to replace Objective-C eventually. So syntax, so just a few basic things just so we can follow along. You've got constant variable, right? So you can, using the let keyword, you can have an immutable value, and then var for variable, pretty straightforward for a mutable value. And then Swift infers type, but you can also be explicit with your type annotation. So just with the colon string, so very similar to like Rust and whatever. So class declarations, right? So class keyword, pretty straightforward. We've got the duck class as we do. So you've got various properties there, duck type, name, owner, and you can see you can see with the owner, like with all of these, we've declared the type, but with the owner one, we've actually given it a value, so it's a property with a default value. And then you've got your initialization method, which is just init, and then you have your texture parameters, right? And obviously, being a compiled language, if you don't either set a default value or initialize all the values that you need to initialize, then you'll get an error. So it's basically it's taking the duck type and name because we didn't give it a default value or anything like that. Class methods, pretty straightforward. So all methods are prefixed with func, func for function. But if you prefix that with the class keyword, you create a class method, which in this case is quack, which just prints quack. Pretty straightforward. Hopefully everybody can see that okay. And then, so instance methods, right? So you've got print duck type, so that's just a straight instance method that doesn't take any arguments, and just prints out a string. And then we've got a change owner one, and the thing I want to highlight with this particular one is it's obviously taking the parameter, and the syntax for that is just a parameter and the type that you're expecting. So in this case, it's a string. And then the last one is get ROOTCON. The thing that I want to highlight with this, and it'll become apparent as I go through it, is you have you can see this sort of duck name and name. So you have the parameter, the argument name, but you can also export another sort of parameter name for that, which is this duck name. And so that'll be relevant a little bit later on, but when we call it, it has certain characteristics. So yeah, pretty straightforward, right? If you want to initialize, you'll create an instance of this class. You've got your flat duck and upright duck, and you've just got your two. You just give it, duck, and then you pass it the parameters for the initialization method. Pretty straightforward kind of stuff. To call a class method, it's just the class dot whatever the method name is, and any parameters if there are any. And then calling instance methods again, the main difference is you're calling it on on an instance of that object. So going back to where we exported that name, you can see down the bottom, when we call that, we actually have to pass in that exported name, so that duck name, symbol, I suppose, as opposed to like if you look at the change owner, where we didn't export like another name for it. You just put the parameter in, and that'll be relevant. I'll explain why that's relevant in a bit, but it's just something to know. So types, so all the basic C and Objective-C types are in Swift or supported in Swift, so string, bool, int, float, the works. You've got collection types, array, set, and dictionaries. Optional types, so you have optional types that work with all types, so you have no more like nil pointers like in Objective-C, which is nice. And it's a type-safe language. So Objective-C compatibility. So Swift has Objective-C compatibility and interop. It uses the same runtime environment. It still supports C and C++ in the same app, but you can't call C and C++ directly from Swift like you could with Objective-C. And as we'll discuss later, the interop and the compatibility component can add for some dynamic features and runtime manipulation. So Swift compared to Objective-C is a lot less dynamic. A lot of the recent changes, and particularly in Swift 4, the roadmap for Swift 4, there's talk of including more dynamic features within Swift. But some of the cool stuff that you could do with reverse engineering Objective-C apps is because of how dynamic it is. But yeah, I mean, this is why it's important from a reverse engineering perspective. But yeah, just note that Objective-C is a lot more dynamic when you bridge them and include Objective-C code in your app. It adds a little bit of that dynamism to Swift. Other language features. So like we've barely scratched the surface. It's just like a quick overview to try and get you guys familiar with it. The structs, protocols, extensions, optionals, generics, error handling, all that kind of stuff. It's really nice first-class modern language, they call it. I don't know what a modern language is supposed to mean, but it's modern. Uses automatic reference counting, so that's been a thing since Objective-C 2. It's pretty straightforward in the memory management. Unicode, so you can come up with crap like that. So I don't know why anybody would want to use emoji in their code, but yeah, it's possible.
Excuse me, Michael, could we cut you off for a minute?
Yeah, go for it.
All right.
Cheers. Sweet. All right, so that goes down really well. Other language language features. Yeah, so there's a free ebook available from Apple called the Swift Programming Language, and it covers a lot of this in depth, and it's a really good overview of Swift and a lot of the features. So if you're interested in finding out a little bit more, definitely check it out. Alright, so what are the challenges reversing Swift apps, and why is it a bit different from Objective-C? So, as I mentioned, it's less dynamic than Objective-C, so that makes it less flexible than Objective-C in some areas, and it can make it harder to do some of the standard tasks that you would do on a typical app pen test. It's less of an issue at the moment because Swift apps will include a lot of Objective-C, right? So even if apps are written, pure Swift in terms of what the developer's written, all of Apple's frameworks currently at the moment are written in Objective-C. So there is an element of bridging there anyway if you're writing, say, an iOS app or an OS X app that uses Apple's frameworks. And obviously there's a lot of developers that are putting their foot in the water by, or dipping their toes in the water rather, by just including Swift in certain modules within their apps. So it's less of an issue now in terms of how dynamic it is because you're getting a little bit in when you bridge it with Objective-C. But it's still a challenge. It's not as neat as we'll see. And there's limited tooling compared to what we have for Objective-C apps. But yeah, we'll explore this in more detail. One of the other challenges as well is there's a rapidly evolving syntax. So API features and all that kind of stuff constantly evolving. And as Apple doesn't really care too much about breaking changes. Breaking changes to the API, your apps, headphone jacks, all that kind of stuff. So you can see the timeline there. We've got just in the span of a few years, we've got a lot of different versions, and it's changing very very consistently. 3 has just been released, and from version 3 onwards, they've committed to a little bit more stability. So it's not going to be changes to the language aren't going to break your apps too often. Other than for major versions. So 4.0, which will be releasing next year, will probably have some breaking changes, but point releases and things like that, no one are going to introduce breaking changes. So when it comes to reversing Swift apps, there's 2 primary reverse engineering activities when conducting a black box pen test. So dumping and analyzing class information from the binary, just to figure out sort of what's in there and what it's doing, and then retrieving information at runtime using debuggers, function hooking, tracing together. Sweet. So retrieving class information. So class dump. So class dump is the most common and the easiest way to retrieve class data from an Objective-C binary. And you've got class dump Z for iOS to retrieve class information, and it formats the output to look like the equivalent of an Objective-C data file. And it's usually one of the things that you do, first things you do when you look at an app, right? Just to get an idea of what's in the app, how it's working, what's some of the stuff that's storing and processing, and how it's working. So that's what it looks like. And this is just Tweetbot on my Mac, so I just grabbed it. So yeah, it looks pretty much like a standard interface declaration, right? You've got your class name, colon, then you've got your superclass, you've got your properties and instance variables, and then you've got your class and instance methods. So pretty straightforward. So what happens though if we run class dump on a Swift app? So that app that I ran through with all the duck crap, that's I just sort of created that app, and we use that for the most part in terms of the demo. So if we run class dump, actually nobody can see that. Okay. Nobody can see my screen. Can everybody see that okay? Yeah? Okay. See, and then we've got the ROOTCON demo, right? Right, like nothing. It doesn't come up with anything, but we know we've got this class. We know that there's stuff. So class numpty doesn't work, which is not cool, right? So yeah, sad things. So what next? So class numpty doesn't work with Swift binaries. So now what? So let's start by diving into the binary. So if we like try and dump the symbols, right? We can see that there's stuff there, right? There's stuff in the binary, and you can see a bunch of different potential classes, right? You see object, see class, you see Swift object, which is the root object for everything in a Swift runtime. So like, what if we search for like something that we know is in there, right? So we know that there's a print duck type method, and we can see some stuff, right? So cool. Like we know that there's stuff there. So even though class numpty isn't picking it up, there is some sort of information that's in there that we can try and extract somehow. But it looks a little bit weird, right? So it's all like mangled and stuff. So let's dive into sort of that. Yeah. So there we go. We dump the symbol table, and then we look at something, we get this. So name. So that looks promising, but it's obviously a far cry from the output of classnum, and it's kind of hard to make out. So the reason it looks like that is Swift stores metadata about a function and its symbols, and in the process it mangles the name, so very similar to like C++ or whatever. So let's try and break it down a little bit. So the _t indicates that it's a Swift method. The capital F indicates that it's a function. The C indicates that it's a class of a function of a class. Then you have the module length prefixed with the length. Sorry, the module name prefixed with the length. The class name prefixed with the length also. Then you have the function name also prefixed with the length. Function attribute. I'll go into the different attributes, but this one is that it's a function. Then you have parameters. In this particular case, if you remember back to the demo app, it actually didn't have any parameters, or arguments, so there's nothing there. And then you've got your return type. Again, it did return there's no return type for this one, so so there's no return type there as well. So the different function attributes. So the lowercase f just represents a normal function. Then lowercase s and g represent your set and getter methods. And then your lowercase c and d are your constructor and destructor methods, and then your uppercase c and d are the allocator and deallocator methods. Return types, again, so A for array, B for boolean, it's pretty straightforward, right? F for float, I for integer, uppercase Q for implicitly unwrapped optional, and S, uppercase S for string. Yeah, cool. So now we know roughly the way the names are mangled. You could use this to create a script that demangles the names. But Apple, being the great guys that they are, has already thought of that and include a utility called Swift Mangle in the iOS or in the like the SDKs to demangle that and to demangle the names and do just that. So let's have a look at Swift demangle. So Swift demangle, it's actually XC run Swift demangle, but let's just set up an analyst, that's why I've got Swift demangle. And if you pass it in, one of these mangled class names, or mangled symbols rather, it spits out the symbol and then a demangled version of that. So you've got There's, the ROOTCON demo is the module name. So it's a pretty simple app. It just has one module. You've got duck for your class name, print duck type for your method, and then obviously there's no arguments and there's no return type. There's a few options with Swift and Angle, which are interesting. So you can have the compact, which doesn't reflect back to your symbol that you pass into it. Then you've got the simplified option as well, which just it gets rid of the module name, so it just has the class, the function, and then everything else that goes with it. But the other alternative, the other interesting option with Swift and Mangle is the expand option, which just expands it out and gives you a bunch of detailed representation of all the information that's sort of loaded up into that symbol. Cool. Yeah. So with this, you should, and some basic shell scripting, you should be able to easily grab the function signatures from an app. It should be all you need to get basically the same information that you would from ClassDuck to start assessing the app. But the obvious issue with that is it doesn't really look that nice. It's not really formatted in a nice way like ClassDuck is. So hack together a little bit of script that enables the name and formats the output to approximate the output of ClassDuck. And because it's written in Swift, because why not? So let's have a look at that one. So if we go, so remember when we ran ClassDump, Z came up with nothing. But if we run ClassDump X, okay. So let's try and find the class that we wrote. Class. Yeah, cool. Right. So so we've got this sort of output that approximates ClassDump Z. It's pretty basic. I'll go through some of the stuff I want to do with the tool later on. Basically, you've got your duck with this sort of pseudo interface declaration, and you've got your different methods, your chain journal, print duck type, and whatever. And going back to where I spoke about the exported names being relevant, it comes through here, right? So if you've got the chain journal, which didn't have an exported parameter name, it just returns the type, where it says, okay, it's a string, whatever the parameter is called, it's a string that it takes. Whereas if you export it, it does show up in the sort of demangled output, right? So you can get that kind of information. And then the other interesting thing to note as well is for your initializer methods, we didn't export any names for it. It automatically does it for your initializer method. So that's why when you call your initializer method, you actually have to put names in there of different parameters. So that's why you put the duck type of name, and then it returns a duck, obviously. Cool. So the obvious caveat with all of this is if the developer strips symbols from the binary, then these techniques obviously won't work. There will be some stuff that's in there, but it definitely won't be stuff that's been written by the developer. So that's one caveat. Reverse engineering strip binaries is a little bit more complicated, and, beyond the amount of time I have to discuss it as well. But there's some things that you can do to at least get some information. That's a talk for another time. So revisiting Objective-C compatibility. So part of the reason why it's so much easier to get class information from Objective-C binaries is because it's necessary for the Objective-C runtime to have all of that information, to be able to run. So let's have a look at what happens when you import Objective-C frameworks or use Objective-C in your app, right? So just revisiting ClassDump a little bit. So the latest branch of ClassDump, which is written by a guy called Stephen Nygaard, it's the original ClassDump utility that ClassDump Z was based off. It has limited support for the Swift and Slider branch. you need to download and build it from source, so they don't have any sort of releases, prepackaged releases yet. But if you just go to their GitHub page, download it, and it's really easy to build from source. No, it's not the right point. I didn't update it from my hackathon, so never mind. I forgot to replace the screenshot. Never mind. I was going to say ROOTCON, which is definitely a better con than hackathon. Come on, right? Thought I changed this slide. Anyway, so we've got this really basic kind of class, right? With this class, it's got some properties, it's got a couple of methods in there. And if we have a look at the class utility, like the latest branch that has Swift support, and well, it doesn't have that much Swift support, but if we run it on this class demo, I believe I called it, you can see it's coming back with a bunch of stuff. But if we have a look, this one actually has ROOTCON, which is the demo. I updated the demo just on a screenshot. You know what? Let's do this. Yeah, so I did update the demo piece. So with this class on that really basic Swift app, no luck, right? It's not parsing. You can see it's not demanding the names. It's not parsing that properly, and it doesn't show up with any functions. And it obviously it can recognize this property for like how great is ROOTCON, but it has error parsing it. So not that great, right? But what happens if we change it up slightly? Yeah, so sad face again. So what happens if we change it up slightly? I really wish I changed the thing. So what's like, if you have a look at this one, I've changed something. I don't know if anybody can see it or spot it. What's different from the previous one? The only thing that's different is instead of, if you go back, this one's just pure Swift, and this I've inherited from MS Object, which brings in all of the Objective-C stuff, right? So MS Object is the root object for all Objective-C, for Objective-C as opposed to Swift Object, which is what you would get if it was a pure Swift binary, but this is now going to bring in NS Object, which makes it a mixed binary, and you have the Objective-C bridging to the so what happens now if I run class dump with that one? There we go. Right there. Perfect. So you can see it there. So it's a little bit better now, right? So it still has an error parsing how great is ROOTCON, but if you look down the bottom, it still recognizes it as a property and a string, which is not right. I don't believe it was a string, but yeah. So but at least you've got the different methods that's in there. It doesn't recognize the argument names like we did with the previous utility. But at least it's the return types of the name. And it's pretty, it's better than nothing, right? So you're not completely, lost with class dump. So there's still some options there. One of the interesting things to know when it comes to like these argument names, obviously we can't get the argument names in this, or even when using the other technique that I showed, unless they sort of export that name. One of the key things when it comes to iOS and OS X programming, there's certain sort of patterns to the way that the developers will name these, there's certain conventions that they'll use when they're naming their functions and whatever. One of the common patterns that you'll see is that the first argument is often included in the function name, right? So in some way, so with the sort of like with whatever, right? So instantiate with name, or like init with name, or in this particular weird case, I've got with runtime, right? And if you have a look at it, the argument was a string which contained like a representation of runtime at Objective C, right? So even though you can't get all that information, you can still use some of those conventions to figure out what's going on. Alright, so yeah, happy days. So what are the other options? So class term in Dilate is the successor to a weak class term, which is a script. I hate that name. And it works in a similar way to a weak class term, so you can import it into script and get that information out. It produces an output that's very similar to the Swift branch of class term, so what I just showed you. Obviously, you can fire it up in a disassembler, Hopper, IDA Pro. I think Binary Ninja really supports it at the moment, but you can fire it up. And obviously, if you want to get some lower level insight into the app and how it's functioning at a lower level, that's what you need to do. There's a bunch of different scripts. I use Hopper mostly, more so than IDA. When you got a Windows license for IDA. And so, there's a link there to some scripts which will denable the Swift names for you. And there's a bunch for IDA as well, so you can look those up. So, like, what about like script and Frida? Like, do those sort of things work if we're trying to get information out? So, we can have a quick look at that. Phone that I have. A bit bigger. Alright. Everybody see that? Alright, so I've just got this like demo app that I've been running for this con and presenting out on the weekend, and it's just like a simple passcode app. You guys can't see it, but pretty straightforward. It's written in Swift. So if we go into this script, yes, sweet. So you can do certain things like you would normally do. So you can get your app instance. Whoops. Right, and then you can grab the delegate, which is a Swift class. You can see there's some limited support for like parsing out what it is. So you've got the module name and the class name. So the script has been updated with some limited support for Swift. But if you do something like you're trying to get all the instance variables, you can see there's some errors there, right? So you've got this passcode lock presenter, which is a Swift class that's in there, there's a bunch of errors of parsing it, and like things like choose, which is really cool, like where you could try and get a class name and just look up any instances of that particular class. Doesn't work. There's a bunch of things where script is a little bit janky. Frida fares a little bit better. I didn't have time to update it for Frida, but you can do some more stuff with Frida. It's more actively updated and developed. But yeah, script is not the greatest. You kind of have to go a little bit more manual when you're using script, as opposed to just using some of these nice shortcuts that are built in. Bunch of looking am I doing for time? I know we're running over, but I'll go through this quickly. So yeah, so hooking Swift methods still possible. It's much easier in a mix with Objective-C binary. So you can still write tweets in mobile substrate, basically. So here you've got this like really basic class, which is just this property greatest ROOTCON, and you've got this initializer which sets it to 5, which is wrong because it should be like a lot better because ROOTCON is awesome. So let's try and hook that to make it 10, right? So you can look. There's a few different options with this. You could hook the getter method, you could hook the setter method, or you can change the variable directly. So you can hook the getter method and that works. That's the hook there. So pretty straightforward kind of hook. Just to change the getter method, which is probably the best way to go if you're trying to do that. You can hook the setter method, which kind of works. So it's just that it's hooking the set how great is ROOTCON method. When I say it kind of works, is that certain functions in Swift are inlined, and obviously the class constructor is one of them, so the init method. And that's what's in this particular case, directly setting the instance variable. Basically in this particular case, the setter will only be called again by the top level code. So if you can call it from there, that works, but anywhere else it doesn't. So that's why it kind of works. And then you can change the instance variable directly. And again, that's the hook for that. It's very similar to the setter method, except for you use the ms hook ivar function. It works, but it's not really advised. When you're running hooks, just generally, you don't really want to change instance variables just because it can introduce weird behavior. It can really mess with the working app. So if you want to keep the app working, you probably don't want to do that. But it works. Anyway, so yeah, cool. So wrap up because I know like lunch is ready. Wrap up. So not all hope is lost when it comes to your standard sort of app pen test workflows with Swift apps. It's a bit more of a pain in the ass if you don't get access to source code because you have to sort of do these sort of reverse engineering techniques, and there's not a lot of good tooling and there's some limitations to it. But you're just revisiting what I said at the start. Most of the issues in iOS and OS X apps are due to poor design decisions, like most applications, right? Or even like misconfiguration or poor implementation of the Apple and third-party frameworks. So like poor transport security, really bad data security decisions, particularly on mobile, that's a big issue. Things like that. It doesn't matter whether it's written in Swift, iOS, or even the sort of multi-platform frameworks that you have now as well. Just keep that in mind when you're going through this. It's not as if you're kind of stuck, but there is some hope. It's probably going to get better. I mean, more and more tools are being developed around this, and more research into it, and it's Swift will become standard, so people will just have to adapt to it, and adopt these new techniques. So next steps. So I want to obviously improve the class script that I had, which was pretty bad. I want to remove the dependency on Swift command hook. So at the moment, it's just shelling out to Swift command hook. To handle Swift the command hook symbol names. Obviously, I want it to be able to run on Linux, which is supported in Swift. If I can, I'll probably re-implement the denabling in it, and looking at getting the properties and some more information into it, and how to deal with Swift script binaries and things like that. Runtime inspection. So script works, but it's not as straightforward as Objective-C. LLDB works, so it's much better, and they've just updated some of the LLDB stuff. So if you're doing black box pen testing on iOS, you can extract the debug server binary or utility from the SDK, copy it over, and then you can debug third-party apps using LLDB. It works really well, and there's really good support for Swift in there. So that's probably the way that I would go. And I'll probably write a blog post on that soon if I ever get the chance. Yep, I see him. What's your name? Anybody got any questions? No? Alright. Too easy. I'm doing the mobile training tomorrow, so if you want to come by and see that and have a chat or ask any questions, feel free.